November 2024, Paper 2, High Level, Question 1. Alkanes are commonly occurring organic compounds. A. The first four straight chain alkanes are gases at room temperature. 1. Explain why the boiling point increases from methane to propane. So alkanes, they are non-polar. Non-polar means they will have LDF, London dispersion forces. So as the molecules become bigger, so bigger will be the London dispersion forces. So bigger the molecule, bigger will be the relative MR. So bigger will be the relative molecular mass. And we can write stronger will be London dispersion forces. Stronger will be London dispersion forces. Hence, more energy will be required. Explain why the volume occupied by a sample of propane increases sharply when sample is heated up from 200 to 250 Kelvin at constant pressure. If we look in the graph, so we have a boiling point of propane somewhere here. So if I say this is around 240, below that up to 200, propane is a liquid. Propane is a liquid. And above boiling point, we will have propane as a gas. So I can write below boiling point, which I read from the graph is not very clear. So if I say 240 Kelvin, sorry, propane is a liquid, and above boiling point, which is so greater than 240 Kelvin till 250, so propane will be a gas. Propane will be a gas. So there is a state change. From liquid to gas. Gas particles occupy greater volume compared to liquid, as particles are further apart. We can also say, according to Charles' law, temperature is directly proportional to volume. Particle gain kinetic energy and they will be further apart from each other. So calculate the volume in dm cube occupied by 6.45 gram of propane gas at 100 kilopascal and 15 degrees Celsius. So we can use PV and RT, ideal gas equation. So PV is equal to nRT. We have to work with the volume, so let's rearrange for volume. Volume will be equal to nRT over P. Let's do the unit conversion. So temperature has to be in Kelvin. So 15 plus 273 will give me 288 Kelvin. Pressure has to be in Pascal. So 100 times by 1000 give me 10 to the power 5 Pascal. Let's find out the moles. So we know mole is equal to mass over molar mass, and mass is 6.45, and the molar mass of propane C3H8, so 12.01 times by 3 plus 1.01 times by 8, so So that will be 44.11. Let's solve this. So if I solve this, moles of gas will be 0.146. So 0.146. Let's substitute these values in the equation. So 0.146. R is a gas constant and its value is 8.31 given in section 2 of the data booklet. So temperature is 288 divided by pressure 10 to the power 5. If I solve this, that will give me 0.00349 meter cube. So let's go back to the question. So the question says volume in dm cube. So converting meter cube into dm cube, we need to multiply with 1000. So we multiply with 1000, so we will have 3.49 dm cube. 4. Outline why the volume occupied by propane gas at very high pressure is higher than the value calculated using PV and RT. So at high pressure, propane will deviate from ideal behavior. So propane gas will deviate from ideal behavior. The volume of individual gas particles will become more significant. Or we can say individual gas particles will have finite volume. Hence, propane will occupy more volume. B. Ethane can be converted to chloroethane by reacting with chlorine gas in the presence of UV light. State the type of reaction and the name of the mechanism by which it occurs. So the type is substitution. And the name of mechanism is free radical substitution. Free radical substitution. So alkane undergoes free radical substitution reactions. Right, C. Chloroethane can be converted into ethanol. So chloroethane is a haloalkane. It's converting haloalkane into ethanol. Identify the reagent and the conditions necessary for this reaction to occur. So nucleophilic substitution reactions will take place, and they are of two types, SN1, SN2. So reagent is sodium hydroxide aqueous, or we can use potassium hydroxide aqueous. Cool hydrolysis as well, breaking down with the help of water. So condition is heat, or 60 degrees Celsius, by writing heat is enough. Alkenes are useful in industry. A. But-1-ene contains sigma and pi bonds. 1. Identify the hybridization of the carbon atoms labeled A and B. If we look around carbon A, we have 3 electron domains. Double bond is considered as a 1 electron domain. So 1, 2, and 3 electron domains. So for 3 electron domains, we are looking for 3 hybrid orbitals. That means 1s and 2p orbitals, they will merge together to give us 3 new hybrid orbitals. Hence, the hybridization around A will be sp2. Let's move to carbon B, and if we can see, we have 1, 2, 3, and 4 electron domains. So for 4 electron domains, we are looking for 4 hybrid orbitals. So that means 1s and 3p orbitals, they will merge together to give us new 4 hybrid orbitals. Hence, hybridization will be sp3. So for A, sp2, and for B, sp3. That will give us 1 mark. B. But1e reacts with HBr to produce 2 structural isomers of bromobutane. 1. Explain which of the 2 structural isomers is the major product. When HBr reacts with but1e, electrophilic addition reaction takes place. So there is possibility of 2 products. So one product will be 1 bromobutane. So let me draw but1e here. So we have C double bond C, we have a H, we have a H, we have a H here, and we have C, H, H, and C, H, and H. So if we add HBr, so one possibility is H will go where there are more H according to Markovnikov's rule, and our product will be 2 bromobutane. And if Br will go where there are more hydrogen, then our product will be 1 bromobutane. 1 bromobutane. 2 bromobutane will be major product. Now we need to explain why. Because 2 bromobutane is formed through a secondary carbocation. So secondary carbocation. Secondary carbocation. Secondary carbocation is more stable as compared to primary carbocation. Primary carbocation. And the reason is positive inductive effect of alkyl group. Positive inductive effect of alkyl group. So there are 2 alkyl groups in secondary carbocation, while there's only 1 alkyl group in primary carbocation. So secondary carbocation is more stable as compared to primary carbocation, hence the major product will be 2 bromobutane. Question 2 continued. Explain the mechanism for the formation of major product using curly arrows to represent the movement of electron pairs. So let's start writing but1e. C, 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 and C. First carbon has a double bond and it will have 2 hydrogens. Second carbon will have 1 hydrogen, 2 here, 2, 3, and 1, 4. We have unsymmetrical alkene. Unsymmetrical alkenes, they form 2 products. And in this question, we have been asked to represent the mechanism for the major products. So major product will be through secondary carbocation. So let's write HBr. HBr is a polar molecule. Hydrogen is partial positive, and Br is partial negative because Br is more electronegative as compared to H. So the role of H here is electrophile, and the name of this mechanism is electrophilic addition. Curly arrow shows the movement of electrons. So we have electrons in double bond. So I will start my curly arrow from the double bond to this H. And the bond between H and Br will break. So this is an example of heterolytic bond fission or heterolytic bond cleavage. So as a result, we will have a carbocation formed, and hydrogen will go where there are more hydrogens according to Markovnikov rule, and we will have a secondary carbocation because question says for the major product. So we'll have H here and positive charge on carbon and 2 hydrogen as it is and 3 hydrogen as it is. So this is a secondary carbocation, and plus we will have Br minus with a lone pair. Now the next step is this Br will act as a nucleophile and it will attack the carbon which has a positive charge. So arrow from lone pair to that carbon, and our product will be 2-bromobutane. So 2-bromobutane will be our major product, and CH and H, CH3 as it is. Okay. So that will give us 3 marks here. So I would say 1 mark for the first 2 arrows, carbocation, and arrow will give us the 2nd mark, and the product will give us the 3rd mark. 3. One of the structure isomers can exist as a pair of enantiomers. State the name of an instrument which can distinguish between enantiomers. So we can use polarimeter. Writing polarimeter will give us 1 mark. Question 3. Potassium and potassium chloride both form lattice structures in the solid state. Predict with a reason electrical conductivity of K solid and KCl solid. So K solid is a metal, and solid metals, they conduct electricity. So I need to write yes. So potassium solid will conduct electricity. And now I need to write in the reason. So the reason is because of movement of delocalized electrons. So delocalized electrons are free to move and carry the charge through the structure. Potassium chloride solid is ionic compound, and solid ionic compounds, they don't conduct electricity. So I will write no. And the reason why, ions, they are tightly packed together. Ions are tightly packed together and not able to move to carry the charge. So key thing here is you must write down yes or no, and then for the metals is the delocalized electron that carry the charge, and for solid ionic compounds is the ions. So the ions are tightly packed together in solid potassium chloride, hence they are unable to move to carry the charge around. So electrical conductivity for KCl solid will be no. 2 electrolytic cells are connected in series. All electrodes are inert. 1. State half equation for the reaction occurring at each electrode in cell 2. Use section 24 of the data booklet. So we're dealing with cell 2, and in cell 2 we have dilute potassium chloride. So the concentration of chloride ions effects on the product. So at anode, oxidation takes place. So oxidation takes place at anode. So both chloride ions and water will be attracted towards anode. But one of them will get oxidized, and is the water that will get oxidized because of preferential discharge. So if we look at the data booklet, when water gets oxidized, oxygen is produced. And why water will get oxidized? Because the value for water is plus 1.23, and for chlorine half cell is plus 1.36. So water will get oxidized, and we can write down H2O liquid that will get oxidized. We'll get half O2 gas, plus we will have 2H plus aqueous, and plus we will have 2E minus. At cathode, so both potassium ions and water will be attracted towards cathode. At cathode, reduction takes place. So let's have a look in the data booklet. So E value for potassium is -293, and for water, when water will get reduced, it is -0.83. So hence water will get reduced and hydrogen will be liberated there. So our half equation will be H2O liquid, and water this time going to get reduced, so it needs to gain electrons, so H2 liquid plus E minus, and on the product side we will have half H2 molecule plus as a gas, plus we will have OH minus aqueous. Right, so careful with this question. If it's a concentrated, then we will get chlorine, but it's a dilute, hence water will get oxidized. Question 3 continued. Identify the product at the anode in cell 1. So in cell 1 we have copper sulfate aqueous, so we have copper ions and sulfate ions in addition to water. So both water and sulfate ions, they will go at anode, and is the water that will get oxidized. Whenever we have sulfate and nitrates, they will never oxidize because sulfur and nitrogen, they are at their highest oxidation state. Hence the product formed at anode in cell 1 will be oxygen. So oxygen, water will get oxidized. Right. 3. Determine the molar ratio of non-ionic products. Non-ionic products formed at cathode, negative electrode, cell 1 and cell 2. In cell 1 is the copper ions that get reduced to copper. So copper 2 plus 2 electron will give us copper atom. And in cell 2 is the water that get reduced. So if I look in the data booklets, we have H2O plus E minus, and we will have half H2 plus OH minus. So if 2 moles of electrons they are flowing, we will get 1 mole of copper, and I guess to form half molecule of hydrogen we need 1 mole of electron. So if we have 2 moles of electron, so we will form 1 mole of hydrogen. So we'll form 1 mole of hydrogen. Or we can write down case type 4 equation as well. So 2H plus 2E minus, and we'll have H2. So the molar ratio will be 1:1. C. State the number of each type of subatomic particles in potassium ion. So in this question we have been given nuclear symbol notation for potassium ion and asked to work out the subatomic particles. So we know Z, which is atomic number, is 19 in this nuclear symbol notation. Hence we have 19 protons, and there's a charge of plus. That means it has lost 1 electron, so hence the number of electron is 18. And the value of A, which is mass number, is 41. So 41 take away 19 will give us 22. So we can say there are 22 neutrons. Outline the evidence that electrons in a potassium atom occupy 4 main energy levels. So if you look at the periodic table, potassium is in the period 4 of the periodic table. So potassium is in period 4 of periodic table. That suggests, so potassium's electrons, they are in 4 main energy levels. So its electrons occupy 4 main energy levels. So hopefully that will give us 1 mark. The second mark, I'll be writing the electron configuration of potassium atom. So potassium has 19 electrons, so we'll have 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. Question 3 continued. E. Potassium react with water to produce potassium hydroxide. Calculate the enthalpy of reaction in kilojoule per mole. When 1 mole of potassium, reacts with water, use section 12 of the data booklet. Delta HF of KOH is minus 481.8 kilojoule per mole. In new specification, this is section 13 now, and equation for delta H reaction is given in section 1 of the new IB data booklet. So delta H naught for reaction will be equal to sum of delta HF naught for products minus sum of delta HF naught for reactants. Okay, so we have potassium, which is element. So for potassium, 2K delta HF naught will be equal to 0 because it's element. And on the product side, for hydrogen, delta HF naught will be equal to 0 as well, so we don't need to worry about them. Okay, so our product is potassium hydroxide, and we have 2 moles of potassium hydroxide, so the value is given minus 481.8. So we'll have 2 times minus 481.8 minus, we will have, if we look in the section 13 of the data booklet, so delta HF for water is minus 286. So 2 times minus 286. Let's solve this. So 2 times minus 481.8 will give me minus 963.6 minus, I will have 2 times minus 286 will give me minus 572. So let's solve this. Minus 963.6 plus 572, that will be minus 391.6. So this is for 2 moles. Question says for 1 mole, so if we divide that with 2, so we will have minus 195.8 kilojoule per mole. 2. Describe the difference between reaction of sodium and potassium with water. So when sodium reacts with water, we get sodium hydroxide and hydrogen, and similarly when potassium reacts with water, potassium hydroxide and water. So they both react with water. Sodium reacts vigorously, so sodium react with water vigorously, and the heat energy produced can melt sodium. With potassium reacts even more vigorously. Potassium reacts more vigorously. Or we can say violently. we can say potassium explode. And produce lilac flame. Number 3. Demonstrate with an equation the acid-base nature of potassium oxide. So potassium oxide is basic oxide. So potassium oxide react with an acid, for example H2SO4, HNO3, HCl. So we'll get salt and water. Salt will be K2SO4, potassium sulfate plus H2O. So let's see whether the equation is balanced or not. So we have 2 potassium, yes we have, so sulfate plus H2O, so we have 4 and 1, 5 oxygen, yeah, so it's fully balanced, yeah.